Okay. Okay, I'm gonna make some adjustments to this animation. I'm gonna change the animation a little bit, and I'm gonna have you keep talking as I change it. So here's the first change I'm gonna show you. Ready? So the lengths of the bars are the same as before. So what am I now highlighting, or what am I showing? And then I want you to keep talking about these two questions. Okay? Go. What am I showing by the gold parts of the bars? So how would you label those? Good. So, does y change at a constant rate with respect to x? How many people think yes? How many people think maybe? How many people think no? All right, I'm going to change it one more time. Watch this. Now, when I do the next change, it's the size of x and the y bars remain the same. Okay, it's not going to change how those x and y are changing together and their magnitudes in terms of amount painted. But what I'm going to do is I'm going to take your friend's bar and shift it back like this. Okay. Okay, go. Talk again. Okay, how many people think yes, y changes at a constant rate with respect to x? How many people think no? Okay, let's start with the no's. Why not? So what are you looking at that you would say, no, it does not change at a constant rate? Anyone want to explain what you're thinking there? Anyone brave enough? How are we doing on computers? I need a walk around. Ladies, TAs, TAs. We need a walk around on computers. We need to walk around on computers, make sure we're focused in. All right, so, especially in the back. Okay, how about yes? Anyone want to argue for yes? There is a constant rate of change with respect to x. Were you going to do it? Oh, he was going to. Okay, go ahead.
The change is, the constant rate of change is always between two changing variables.
Okay.
dy over here should be going at about half the speed dx would be.
Not about speed. It's not about speed, but you're on the right track.
dy is 1/2 of
Do you see that dy is always 1/2 of whatever dx is? Yeah, it is, okay? It is. Trust me, it is. dy is always 1/2 of what dx is. All right, so I'll say it. dy is always 1/2 of what dx is. Does y change the constant rate with respect to x? Who says yes? Everyone in the room should say yes now. dy is the same as 1/2 dx. dy equals mdx, right? Do you see it? I'm asking if y changes at a constant rate with respect to x. Does it? Yes, because that's about a relationship of the changes in y and x. This relationship, that the change in y is always a constant multiple of the change in x. In this case, it's 1/2. It's always half as much as the change in x. The additional amount that you paint, the additional amount that your friend paints, is always half of the additional amount that you paint. Question, yeah?
So how would you represent the starting point of y?
How would I represent, what do you mean? This,
So like for x, the black bar would be like dx plus 2, right? So the black bar, the starting point of y, how would you...
they have some starting amounts, right? So if I just stop it,
So that's
right now, who has painted more? Your friend has painted more, okay? But now we're going to, so this is how much you've painted so far, but now we're going to start painting together. You and your friend are going to start painting. Your friend always paints half as much as you paint together. So I think if you're still not convinced, I think the next thing will convince you. Any questions before we go on? All right, I'm going to show you the same thing. Yeah, please. It doesn't matter what the lengths of those are. It's just the starting amount. That doesn't matter. Did you guess that? Yeah, so x should be 0, x should be this much, x should be this much. If they're at a constant rate, it's about comparing the changes. It's comparing about the changes. But I think this will really help, okay? If you're still not convinced. Here's the exact same thing, okay? Here's the exact same thing. Watch it. Ready? This is the exact same thing that I showed you at the beginning, where the change in y is always half of the change in x. So these are the exact same two bars, just a different little view of it. I'm going to take the bar that represents how much your friend has painted, I'm going to turn it up vertically and stick it on the end of the bar that represents how much you have painted, okay? All right, so again, here we go. Ready? I'm going to do it when it's starting. So ready? Watch. I'm going to take that bar, and I'm going to turn it, and I put it on the end of the X bar. Okay? So this is still that same bar, changing with the same coordination, correspondence points to X as it was before. It's just oriented differently. Okay? And so if I were to put that on a graph, so these now are all correspondence points of how much you painted, X, and how much your friend has painted, Y. Okay? So if I pause it at any time, we get a correspondence point of how much total I painted, or you have painted, and how much your friend has painted. And so if we get a display of all those coordination points, what will we see? I forgot to save it so that it would show this over here. Okay, so these lengths of these bars are the same as what I showed you on the previous screen, showing you that it's about the changes. It's not about the values x and y, but it's about the changes that results in constant rate change. Because all those correspondence points then fall in a line, right? A linear graph of all the correspondence points reflects that y is changing at a constant rate with respect to x. Okay. Okay, so let's look at that. So here is so we have this relationship that for however much you paint additionally, your friend paints half as much. Okay? That's what we've got. For however much you paint, your friend paints half as much. So let's say that this is the correspondence point 4. I don't know, I'm guessing 4.6. Good enough. Does that look about right? Is that a good estimate? So we'll just call it 4.6. There's the correspondence point. So, are these changes in amount painted or total amounts painted? Yeah. X and Y are totals. Is it not right? Sorry. I don't know where I got that. 3.9?
Yeah, 3.93.
Okay. So we'll do 4, 3.9. Great. Okay. So these are total amounts or changes in amounts painted? Are these X and Y coordinates or dx and dy? X and Y. Okay. So I want to find another correspondence point, and I can do that, say, by taking a change in X of why isn't that changing? There we go. So let's take a change in X of 2. So what did I do? I was here at 4, 3.9. And I just painted 2 more square feet. Oh, this is hundreds of square feet. Sorry, these are hundreds of square feet. But anyway, so I just painted 200 more square feet. So that's dx, right? dx is 2. And so I was at 4, and now I was at 400, and now I'm at 600. Okay. When I painted those additional 200 square feet, how many additional square feet did your friend paint? And how do you know it was 100? Always half, right? So everything's in hundreds. I painted 200 more. Every time I paint 200 more, my friend paints 100 more. So this new correspondence point is, I painted 400, I painted 200 more. How much have I painted now? 6. Your friend had painted 3.9. They painted 100 more. How much have they now painted? And so where does that 4.9 come from? That is like a Y final. And how did we get it? Which we worked on hard, right? We've worked hard on that. Plus dy. And dy we got by m dx. Oh, so I hope these sighs and groans aren't, well, this is so easy, because this students just don't get this quickly. You got to plug in and don't.
Plug and chug.
No, not plug and chug. Understand. Okay. I meant plug your brain into what the conversation is, and don't think this is super easy. Okay. So let's do it again. So I want you to find the correspondence point. Let's go back to 4, 3.9. And I want you to find the new correspondence point with this process for, let's see, for a final x of 8.7. No, take it back. 9.3. Okay, so you're gonna start from the corresponding point 4, 3.9, and so I'm gonna paint some more until I reach a total of 9,300 square feet. I want you to execute the same process to find the total amount that your friend has painted once you reach 9,300 square feet. Go. So you can execute that process again. Go.
There's this new invention called paper, and you can write on it.
Yes.
So let's do that.
Yeah. You're gonna. Yes. Thank you. I should have said that. You need to be writing as you're thinking and talking. Okay. Write it. Okay. Let's see. What's the X? dx is 5.3, right? Where'd that come from? Okay, so how are we going to get, so what do we want next? We need the corresponding change in y, and this is easy because we have constant rate of change. How do we find dy? Your friend, the additional amount your friend paints is always half of what you paint. And I saw that, is that 2.65? So dy is, we get that from m dx, and that is 2.65. What is the final value of x? That's what I gave you. How do we find the final value of y? Initial, your friend had painted 9, or 3.9? Painted 2.65 more, so it is? plus dy. Final value of y is the initial plus change. Initial was? $6.55? Okay. Wow, lots of yawns and sighs. I guess this is really easy. Okay? Any questions? Yeah.
The one question that keeps on coming up for me is in the wording when it says there's a constant relationship or a constant change
Rate of change.
between x and y, which
Yep.
is 2. Which one is 2 in that situation? Which one is y? Or which one is 2? X or
So we normally talk about the constant rate of change of the dependent with respect to the independent.
Okay.
So when you have a constant rate of change, it's
First.
dy divided by dx. It's the change in the dependent per change in the independent. Does that help?
Yes, thank you.
Okay, so we just found 2 more correspondence points. We found that one, and we found one around here. I don't remember what it was. Or around here, 5. But now I want to find every correspondence point. And I don't want to do it one at a time. I want to find every correspondence point. How can I do that? The way I can do that is we had our initial point there. We could choose any initial point, 4, 3.9. And now I want to find every correspondence point on this line. So I'll just pick one. And I don't want that to represent whatever 7.2 and 5.2. I want it to represent every correspondence point. So what should I call that? In order for it to represent every and any correspondence point on that line. What is it? It's an amount that I've painted and an amount your friend has painted. X and Y. Did you say that? Oh. Yeah. So by just making the final point, not looking for a particular one, but X, Y, now it represents every correspondence point on that line. Okay? So I want you to do it again. So I want you to find Y final. And hopefully there's no more yawns. What is Y final? Okay, go. Go. We're finding every correspondence point on the line now. Who knows what's going on? Yeah. Show me. What'd you put for the X? What's the X? X minus 4. So what's dy? 1/2 times x minus 4. What's dx? Here's where what's dx? How much does x change from 4 to x? X minus 4. Final value minus initial. Final value of x minus initial value of x. No different. Except that now x can be anything. X could be any x value. But then this preserves dx. X minus 4. Final value. What's dy?
1/2 of dx.
1/2 dx, which is? Write that out. All right, so this, then our change to any point, any other correspondence point on the line is dx, which is x minus 4. The corresponding change in y, if it's constant rate of change, we have a constant rate of change, it's always 1/2 times the change in x. So 1/2 times the change in x. Y final is
3.9 plus 1/2 x minus 2.
3.9 plus the change in y.
Distributive properties.
No, just leave it. Just leave it like that. So this is then what? It's an equation represents every correspondence point of how much you paint and then the corresponding amount your friend paints. How much you paint. If you replace any amount that you've painted with x, this will tell you the corresponding amount your friend has painted. It gives you every point on the line. And if you look at that, the whole process is shown, right? So what do you see the dx. You see the dy as m times dx, and then you see our other thing we worked on, y final is y initial plus the change in y. So everything is shown in that relationship. Just don't multiply it out is what I'm saying. Don't multiply the 1/2 out because that's showing the whole process. Change in x, change in y. I'm doing this on the screen for the video. Change in x, change in y. Change in y plus initial y is the final y. And then we get every single correspondence point. All of those points on the line. Okay, anybody have a question? So then, we'll leave it at that. So this is, we're going to move on to another example. Other questions? We saw this one before. Suppose you open your laptop during class to take notes. 35 minutes after class starts, the laptop battery has a 41% charge. 75 minutes after class started, battery is 28%. Percentage P dependent, so I'm putting on the vertical axis, is the percentage of battery power in your laptop. And then time in minutes since class began is on the horizontal axis, so I think our x quantity, and that's the independent. So I graph those two correspondence points. And we're thinking about the same process, thinking about changes in x, corresponding changes in y, that generate all correspondence points of time since class started and battery percentage. So I want you to find the relationship of P and T. Find the relationship of P and T, practicing this process that we're working on, okay? Meaning, find an equation that gives every correspondence point. Find an equation that gives every correspondence point, which is like the purple ones, okay? Like the purple ones. So the red is the first one, blue is the second. So the purple is at any correspondence point. Find the relationship that gives us that purple point. Go. Okay, so most of you discovered that to do this, you need the constant rate of change. The constant rate of change is dy over a corresponding dx, which is negative 0.325% per minute. Who can explain what that number means? Negative 0.325% per minute. Let's see if we've learned anything. Yes, sir.
For any change in time,
Okay.
the corresponding change in percentage is negative 0.325 times that.
Okay. What do you think? For any change in time, the corresponding change in percentage would be negative 0.325 times that change in time. Morgan is clapping. Were you going to say something? Is that what you were going to say?
Yeah, just any change in minutes, that's what we're saying.
Yeah, time. So including time and minutes. Okay. So it's so much. So in 1 minute, yes, the percent goes down. Negative 0.325. Absolutely true. Every minute, the percent goes down. Negative 0.325. But what he said is a lot stronger. That given any change, not just a minute, any change in the number of minutes, you know what the corresponding change in your battery is. It goes down negative 0.325 times as much as that change in minutes. Again, that's dy equals mdx. Okay, so now that we have that, we should be home free. So I'll just pause this here. And so I'll just call that our generic any xy point. Somebody new. How do we start? I want to write the relationship that gives me every correspondence point of minutes into class and my battery. Yes, sir. All right, so he laid it out. So now somebody tell me how I'm going to find dx. He laid out the scheme. Yes, sir. So tell me. X minus 35. If we start at this point 3541, which is what I'm showing in the illustration, dx is x minus 35. Right? That works for any x. No matter what x I pick, dx will always be x minus 35. Okay, somebody new. What do we do next? Yes, sir.
dy.
dy. And what is it?
It's going to be negative 0.325 times dx.
We just said, given any change in x, the change in y is negative 0.325 times as much. So let's do that. The change in x is x minus 35. The change in y is negative 0.325 times as much as that. Finally. So now we're really finding this right here. What is that final value of y given any value of x? Somebody knew. Somebody knew. Yes?
41 plus dy, so it's 41 plus that whole thing.
Initial value of y plus the change in y.
Yeah.
So what does that represent? That represents every correspondence point of a number of minutes since class started. So you can put any number of minutes since class started in here. And this expression right here will generate the corresponding battery percent. So let's have GC do it. Ready? I'm going to say y equals 41 plus negative 0.325 times x minus 35. Now, for what values of x does this make sense? For what values of x does this make sense? X is time since class started, so maybe greater than 0. And then your battery's going to run out eventually, but we don't know when. Do you know when? Did I make a mistake? No, we're doing it in percent. That quantity, we're just doing it in percent and leaving as percent. Yeah. Because these are all like 10, 20, 30, 40, 50. Those are percent. So let's just do it for x greater than 0. So just since class started. And what are we going to see? What are you going to see now? This is what this is going to do. It's going to grab all the correspondence points. That's what we wanted. All the correspondence points of a time and a percent battery. The things they didn't teach you in high school about graphs, right? This is what graphs are about. A set of correspondence points. What are we going to see? You should be thinking we'll see a line through those two original points that we had. Why? Because that equation represents every point given the time the corresponding percent battery change. Any questions on that example? Does it make sense? If you're not sure about something, ask. Let's talk. Let's discuss. Yes, please.
Why?
Don't pack up. Please don't get in the habit of this. My Cal 2 class, no one moves a muscle until I say class dismissed, and sometimes that's a minute late. It's amazing. Like why is that? So please do that too.
So when you tell us to like write the equations, why are we putting it in the form of y instead of x?
Okay, great question. So it has to do with what x is and what y is, right? So what do we call the x variable? What do we call it? Independent, and what do we call y? So that, does that answer your question? Because it's like, we're going to pick what x is, we're in control of x, it's independent, and then y is dependent on that. Depending on what you have for x, you're going to get a certain y. Yeah, but if we rearranged it and put it in GC, we get the same set of points. We get these x, if we arranged it and it did x equals whatever it would be in y with the algebra, we get the same set of points. Good question. Any other questions? But yeah, it has to do with x is independent, y is dependent. Okay, so because I want you to devote all your time to studying for the exam, there won't be homework, but I am going to post this problem. This. So I want you to just, I will post this to work on, okay? So the temperature in percent Fahrenheit, degrees Fahrenheit changes at a constant rate with respect to the number of times a cricket chirps in a minute. And this is actually a true situation, okay?
You're not making a level.
Thank you. You count 100 chirps when the temperature is 98 degrees Fahrenheit, and you count 96 chirps when the temperature is 81 degrees Fahrenheit. So some tasks. Great for studying for the exam, okay? Given that our goal is a relationship that gives a temperature as a function of number of chirps, define the following specifically and with units: x, y, dx, dy, and m. Which of those 5 letters are variables and which are parameters? And then find the values of all that are parameters. Okay. Use the reasoning that we learned today to find the correspondence point associated with 89 chirps. A relationship that defines all correspondence points, and then define a function named c for this relationship according to how it was specified in number 1. So lots of good stuff there for the exam. Certainly not a comprehensive review by any means, but a good review of recent things in the class.